I'm not. You're being very loud.
Alright, today we're going to take a look at a couple of properties relating arcs and chords. Okay, so if you remember, a chord is a segment that connects 2 points on the edge of a circle. Okay, so RS would be an example of a chord here. Okay, so the first property that we're going to look at is that in a circle, or we can actually talk about congruent circles, but we're mostly just going to talk about one individual circle.
We similar. I mean, all circles similar.
All circles are similar, yes. That is true. Alright. So the property is two minor arcs are congruent if and only if their corresponding chords are congruent. So, in this picture here, we're saying that the length of RS and the length of TV, right, if those two lengths of those chords are congruent, then their corresponding arcs are congruent. Right, then we can say that arc RS and arc TV are congruent. And to denote congruent chords, we use the same notation as we do for congruent segments. We just put the same number of tick marks or dashes on there. Right? So, if we look at this first example problem, it tells us in circle K, arc AB is congruent to arc CD. Right? So I know that these two arcs are congruent. From that information, we want to find X. Right? Well, if the arcs are congruent, that means their corresponding chords are congruent. Yeah, so we would just set those expressions equal. 2x plus 3 equals 8x. Subtract the 2x over. 3 equals 6x. Divide both sides by 6. Yep. We get that x is a half. Questions so far? So, congruent arcs means their corresponding chords are congruent, and vice versa. Chords means their corresponding arcs are congruent. Okay. What's that? Oh yeah, we didn't finish the problem, did we? Yeah, it says find AB, so we would need to plug that back in. So AB would be 8 times 1 half, which is 4. I think you're wrong. Let's. Any other questions so far? Alright, then let's take a minute or two and try a couple of these down below here. Just a couple minutes. Arc RT is 64 degrees. And we would find RS. Yep. Because we know that if these chords are congruent, these would be congruent, so we can say that's X as well. Too late. I guess. It's a PCG. The meniscus is basically the padding.
It's 216.
That's what I
What? Why is it so easy? What? It is? What is the 4 supposed to be? What's the 4 mean?
4 is just telling you that these two things here. And that means that they're
Well, I mean, then that would be right then.
there. Okay. The only thing that I didn't like about that is
That was like 90 degrees. I don't know. Okay.
I don't
know.
What does it say?
I got it.
Of them. There were 4.
That's
It wants the central angle measure. So like
we
this,
did 2.
this angle.
We did 2.
Yeah. Well, one thing we talked
Yeah.
about last week is that the central angle is equal to the measure of its intercepted arc. So x equals 116.
Shut up.
I should try that sometime.
I think I used it.
You know, invited.
Five is 7.
It seems like this guy. I got this man, Justin. What are you doing? Don't do it.
I just have an X equal 4 for you.
Feel it. I'm good in my head. 3x, 6, x equals 6. X equals 2. What? That's 9 too late.
Yeah.
X equals 2 for both of these, right?
That X is 6.
For which one?
Because
Oh wait, 8. Talking about 6 and 7. What did you get for 6 and 7?
oh, for 6 and 7 I got 2.
I said both of y'all.
Okay, so I thought you were doing that.
Yeah, okay. You got 6.
Yeah.
And I.
Here's bad bone.
But 78 is nice.
What?
78.
Hey, shut up. Oh, dude, mine is. You don't control me.
You're gonna have that guy.
And that'd be a no. I wish I had a calculator.
Isn't there actual letter?
Oh yeah, let me spell it out. I have to do a math problem. It is 6 divided by 2.
You'll never run your 6 divided by 2 without a calculator.
No. Now the problem is finding the letters. I mean the
I
numbers.
think it comes up to a whole number. It's the bottom. So we would just be setting 2x plus 4 equal to 3x plus 2.
Minus 2. I don't want to play it.
I'm so proud of you for taking the time for this.
You looking at it? What? Wait, what's this? I'm gonna do something.
What?
Do something. I can't wait. Are they still in Madison?
Playing backyard football. Yeah, I enjoyed football. Somebody fell on it. And it didn't work for it. And so they was just a minor tear at that point. But then I never had it checked out. You know, I just figured it would go away. But so it got worse and worse. And a couple of weeks later, like I squatted down to pick something up. And what they determined happened is like the piece that flipped over into my middle of my knee. This happened. I can honestly
No, get rid of it.
It was so bad that they just had to knock it out longer. So like the recovery, I walked out of surgery because it wasn't healed. So I wanted to probably later in life, but now I'm fine.
I scratched my chin and on my leg. And that was really good.
Right now.
No, Micah.
It's in the school.
Yeah, is it? I mean, that is the argument.
That's a nice router. That's
Or you could give him Minecraft for 11 hours.
no, it's only more straight for 11 hours. It's funny that he
For Honors, Warfare 4, and the Holy Trinity right there.
we're Trinity of dead games. Literally, we cannot find a dimension.
Oh yeah, I know. No, yes, exactly. I know the game's doing really bad this year. It's gonna fail so bad. There's no way there's anything.
They should make it like rain.
Alright, take a look up here at the answers.
Gonna be popular.
Right? Are there any that we want to take a closer look at?
Oh, they suck. Oh, wait, no. Never mind. 5, 7, 2, 6. Perfect.
Can you give a 100-point quiz on this section?
Yeah,
Just
please.
this
Oh, yeah,
section.
Well, it seems like you guys have done pretty well with everything so far.
Yeah.
So,
I don't remember what we did.
well, we've only done half of this section so far.
Just this part of the section.
How about half of the quiz be? Or maybe a 50-point quiz.
We're gonna do one more section, and then we'll take a quiz over the first 4 sections in this chapter.
Oh my gosh.
I'm not gonna fail as fast.
Alright, so let's flip over to the back then. Okay, this seems to be going pretty well.
Is that quadratic?
Alright, so on the back,
I thought you were being serious about quadratic.
on the back, the next property that we're going to take a look at is that in a circle, if a diameter or radius, either one, is perpendicular to a chord, then it bisects the chord and its arc. Right? So in this figure, we can see that radius OW is perpendicular to chord AB. That automatically means that AX and BX are congruent. Right? Bisecting means it cuts it perfectly in half. And then it also means arc AW and arc BW would be congruent. Okay. We know that just because the radius or diameter is perpendicular to the chord. Okay. Cuts it exactly in half and cuts the arc in half. Then, the second bullet is pretty much the same as the first. Okay, a perpendicular bisector of a chord is the diameter or radius. And then we could say, in a circle, or again in congruent circles, two chords are congruent if and only if they are the same, if they are, I guess to make it one word, right, equidistant. Same distance or equidistance. It's kind of a big word.
It's not a big word. I know the word.
It is a real word. Equidistant.
No, one word that you know how to pronounce.
Water.
It's not a word. Chaotic.
Melon.
That's it.
They just didn't want to keep writing equal distance all the way.
Or maybe they were doing that and it just kind of like started to spur their words together and they're like, hey, that's a word. That guy's pretty smart.
Maybe so. So, what that also means, if we're looking at this figure, okay, if we know that these two arcs are congruent, AB and RS, then their distance from the center is the same. So I can say that OY and OX, those distances would be the same. Right? If these chords are congruent, their distances from the center are the same. Right? So, if we look at this example here, okay, what we are told is that CD and OE are perpendicular. And then I know OD, which is a radius of this circle, is 15. And I know that CD, this entire length of this chord, is 24. We want to find the length of OE. Right? So this is going to be some more right triangle stuff. Right? We end up using Pythagorean theorem here. So if I'm looking at my right triangle over here, if I know that CD is 24, what's ED? 12, right? Because the radius would be a perpendicular bisector of the chord. So then, we're just looking at this right triangle to find the length of OE. Okay? So we can use Pythagorean theorem, or in this case, this might be a Pythagorean triple. Recognize that. You can always use that idea. Okay? But if you don't, that's perfectly fine. So let's see. Our two legs would be 12 and our unknown. The hypotenuse 15. So 144 plus b squared equals 225. Subtract the 144 over. B squared equals 81. So we get that b is equal to 9. So the length of OE is 9.
That's similar.
recognize that this is a Pythagorean triple, you don't have to do any work. And it's a 3, 4, 5 multiplied by 3. Okay?
I didn't even do it. I got it right.
Alright, questions so far? Alright, then let's jump down to some of these exercises here. No, we're not really going to do any circle proofs.
Thank you.
Right, so, if we look at this first set of exercises, right, I'm told the radius is 13, RS is 24, and I want to find RT, PT, and TQ. Right? So, how would we set something like this up? Magic? Okay, so we can say PQ is 13?
Yeah. And then RS is 24.
So we could say that both of those pieces, RT and ST, are 12. So that answers the first question. Right? RT is 12. But then I want to find PT. So if I know that PQ is 13, how does that help me find PT? Where? Over P? Like, just draw a line like that?
No, like, you put P as your eye. Right here. Like, that's your single point here.
So, the radius is 13. We can draw a radius anywhere, right? As long as we're going from the center to a point on the circle. So I can draw the radius of PS. That would be 13.
That's big.
Then we have a right triangle. Where PT, okay, is the one missing side. That's 7. This is a Pythagorean triple. It's 5. Right? 5, 12, 13 is one of our Pythagorean triples. Okay? So PT would be 5. But again, if you don't remember the Pythagorean triples or don't recognize that, you can always use Pythagorean theorem. Right? So we could set this up as 12 squared plus b squared equals 13 squared. Yep. So then, how would we find TQ? 13 minus 5. So the radius is 13 minus that piece, so that would be 8.
That's because I saw the answer.
Right, so one of the big ideas, I guess, when we're solving circle problems is you can always draw in a radius. Okay, even if there isn't one drawn in for you, you can always draw in a radius.
Wait, how do you know how long it is? Do you have a number? Oh, okay. They tell you radius, not
Or diameter. If they tell you the radius or the diameter, you can always sketch in a radius. Numb or dumb? I don't know if I've ever felt physically numb. Alright? So, why don't we try 4, 5, and 6 here then? I want you to.
Are you fishing for stealing it?
So on number 6, I think this one doesn't work out to a whole number. So simplify the radical when you get there.
Every time it says that, just ignore it.
Oh, it does say round to the nearest hundredth.
Oh, why just simplify it?
Yeah, for our purposes, for this, let's round it, or not round. Let's find the exact value.
For number 4,
How do
why
you
would we
how do you
get 5?
get FDs for? How do you know
So
what
our
FD is for?
CD is 90.
FD is for.
Our DE, we have that.
Because any value.
FD is for.
That'd be nice. Yeah, that was the first one.
Oh, I see what you're saying. So this angle right here, angle EFD, is not a central angle. The vertex isn't at the center. That idea that the intercepted arc and the angle are equal only applies if the vertex of the angle that we're looking at is at the center of the circle.
CD is
CD. Oh, it's just. It's on you.
I just wanted to
It's a
show it.
Pythagorean triple. It's not. Yes, it is. 2, 3, 4.
Alright, did we get 45 degrees, 4, and 2 times the square root of 5?
Obviously.
Questions on those? Alright, real quick, okay, the last 2 have to do with the last bullet point up top, okay? That if 2 chords are congruent, they are equidistant from the center, and vice versa. So in number 7 here, I'm told that these chords are the same distance from the center. They're both a distance of 6. That means the chords are congruent. So I'm told that TS has a length of 21, and UV has a length of 3x. So if these are congruent, if the distances are congruent, then the chords are congruent. So I can just set those lengths equal to each other. Divide by 3 and get x equals 7. Okay?
There's no X on it. X on it.
Yeah.